now we'll have Q&A session, or I would prefer to say that a panel discussion probably. We have number of questions from our audience, which I would like to voice to our speakers now.
Okay.
And when I will have a secret question to every speaker at this panel about Java, of course. So uh, we have a question to Dmitry. Dmitry, you mentioned that the ARM servers available in cloud at AWS. Do you know any other um, cloud providers or manufacturers of ARM servers where we can get where we can buy or get access to an ARM server?
Yeah, I mentioned that in the end of the talk. So you can rent a server built on top of Ampere Ultra in Oracle Cloud or in Azure, or you can buy your physical server from multiple vendors, again based on Ultra. So Gravitons are available only in EC2, but if you need Ultra, you can buy a physical one. There are also
Yes.
others, of course, and other clouds as well, like Alibaba, Yotan, or whatever.
Very, very interesting. I found that the instances on ARM servers and on Gravitons at AWS Cloud is really cheaper than the Intel one, so it's definitely worth to check. And we have a question to Mary. Mary,
Okay.
yeah, we know several different streaming technologies like Apache Spark, Apache Flink,
Sure.
and you gave us the introduction of Apache Pulsar.
Mhm.
Can you briefly explain the difference between them, if that will not take
That's
another half
right.
an hour?
It can take a whole day. No, I'm just kidding. But real quickly, right? So Apache Pulsar is more the event streaming broker, and it's ideal for doing messages ingestion. So more of the streaming kind of front end, if you may say so. And then Apache Spark is actually more of a batch type of processing for streaming kind of data. So it's ideal to, I think there are lots of folks using it for machine learning type of applications or AI type. And then with Apache Flink, it's slightly different too, because it allows you to also for ingestion, but then its main thing is really in kind of the event streaming, kind of processing kind of aspect too. And so I would think, yeah, and so I would suggest that you can actually use it in combination like Apache Pulsar for ingesting data and then basically pass it on to Flink for further processing, because you can do kind of fancier kind of SQL message selection type of thing to it too. So to all your streaming data. So yeah, so you kind of use them all kind of together, kind of a nice combination. Use them for each of their own strength. So yeah, I
Okay,
hope that
so
answered the
they
question.
accompany each other and provides additional benefits if we use them together, as I understood.
Yeah, that's right. Yeah, yeah.
This is great. Yeah, we have another question is like, can the technology you described help with fraud detection?
You're asking me.
Yeah.
Yes, in fact, that's what it is. Like Apache Pulsar, we kind of suggest that you can use it for, again, right, more like your monitoring systems, let's say investment company, financial especially. I think that's where strength can, you can kind of tap into the strength of Apache Pulsar. Think of it more like in ingesting data. Your process is watching the data that comes in high volumes, right? So many large institutions, you have all these accounts and things like that. So you can like monitor any type of unusual activities that happens, and then you can immediately kind of signal right to account holders, well, something is wrong. All these kind of things, you can write logic to kind of interpret any kind of suspicious activities, things like that. So yes, of course, yeah, you can think of using event streaming software to help with your fraud detection kind of purpose. So yeah.
Yeah, of course, of course. So in that case, we need to analyze the enormous number of transactions which are going through the financial institution. And the next question is more technical one, but um, our participants are worried about garbage collection, like stop the world thing, what might happen, and froze the whole stream process and think how Apache Pulsar deal with that, with the stop the world thing.
Stop the world because of the garbage collection. That's a very good question, actually. Yeah. Currently, I don't have the exact answer for that, but if you can give me some time, I'll go dig it up and kind of look that up for you
Okay.
because it
Okay.
is
I
more
gotta
deep.
have
Yeah, maybe
a
like
help a
Dmitry.
question.
Sure.
Help a question. Probably it's federated, right? So not a single node at the time can produce
That's
the incoming data.
yeah, that's right. Yeah. So yeah,
So you have to be very unlucky to have stop the world pauses at the same time.
yeah,
Yeah,
yeah.
yeah, absolutely.
True.
It should have a cluster of nodes and split the stream between them. But yeah, we'll let Mary
Yeah.
to
Let me
get
dig
that.
it up.
Okay,
Yeah.
sure.
Okay.
And more. The question for you is. Can you please share your experience of using that technology you explained in production? Do you use it in
Sure.
production, or that's
So because
just
I had to actually shorten my presentation a little bit, I was basically going to I was planning to kind of go into details of using OpenShift, which is basically built on top of Kubernetes and brings along all the brilliant features of Kubernetes, but it bundles it with some essential features that ultimately provide the best experience to both developers and operation engineers. So that was the part that I was going to explain later, but given that my talk was only 20 minutes, I couldn't actually go into details of that. So what we're using at Discover is actually OpenShift, a container platform from Red Hat or IBM, let's say. Um, and again, being at IBM for 5 years, I dealt with a very large number of clients across Europe, Middle East, and Africa. So many financial services companies that they wanted to actually delight their developers and make their developers more productive. And again, using Kubernetes is great, bare metal Kubernetes or a flavor of Kubernetes on, any one of the public cloud providers. When you go to OpenShift, obviously you get a number of features that makes it even easier for your developers. Like you can point your cluster, your OpenShift cluster or Kubernetes cluster, to a repo, and everything else is going to be taken care of by OpenShift. So you can easily just containerize your application, deploy it, gives you the sort of URL, and then you can actually see what's actually going on in two different perspectives of developers and operation engineers, like administrator in your console. And it comes with a very nice console as well, web console, that you can actually view everything through a user interface rather than CLI, which makes it much easier to kind of manage everything. You can see the number of pods running, you can see how things are scaling, which ones are actually getting hit, if there is anomaly, like when we were talking about for instance fraud detection or anything like that. It actually makes it easier for you to even drive insight from your application and see what's happening in terms of your firewall rules, in terms of the RBACs, role-based access control, and all those things. Like it gives you a great flexibility. And again, when it comes to CI/CD, as I said, you can just point your cluster to your Git, and everything else is going to be taken care of by OpenShift. And that's the beauty of OpenShift, because it kind of bundles Kubernetes with so many essential features. So that's basically my experience, Alex, with Kubernetes in production. Again, mainly OpenShift, but yes, I'm using a lot of for my hobbyist projects. I'm using Kubernetes on so many levels, like even on Raspberry Pis you can have, or your computer, you can even have Minikube, for instance, easily run it on a single node cluster on Intel, for instance, processor. I've got a big Raspberry Pi cluster here next to me that I'm still kind of exploring with that. I can actually show you that one if it works. No, it's not this one. It's right there, as you can see. This is my
Cool.
Raspberry Pi cluster, 125 Raspberry Pis all bundled together. But yeah, so apart from production, yes, I've dealt with Kubernetes, bare metal, and different platforms and servers.
Very, very interesting, Mo.
Very
Thanks a
cool.
lot. So as I understood, the transfer of that solution between different clouds providers or on premises is quite easy, right?
So it depends. So basically, every cloud provider comes up with a flavor of Kubernetes, and they basically bundle it with their own plugins, with their own even UI dashboard. So many kind of connections for database, frameworks, or machine learning frameworks. Again, it depends. When you do it on OpenShift on an AWS, on Amazon Web Services, on Google, and Azure and IBM Cloud is exactly the same version. As far as my years of IBM basically goes, you can actually build your application once. Again, that was the promise of Java a long time ago. Build it once, deployed anywhere. So you build it on OpenShift on AWS, and you can easily port it onto IBM Cloud or back and forth. So that basically gives you that flexibility. Whereas with Kubernetes, you still need to do a little bit of rewrite. You need to kind of change some of the modules, and it's not like a lift and shift. Because again, every cloud provider, public cloud provider, they've kind of built their own flavor of Kubernetes, which in some cases actually works better than the other ones, again, depending on your workload, your applications, but it's not like as easy or seamless transfer as you can imagine. Whereas with OpenShift, actually, it's much easier and faster. I've seen clients moving their applications from Azure to AWS, and vice versa, basically very quickly. Yeah.
This is interesting because all cloud providers also has their kind of variety of APIs for databases, Kafka, and some like services which our applications usually use. So I thought that the main issue should happen on this side, like with other services. Did you match any issues there, or they are resolving pretty quickly?
So what I can say is, like, when you look at the OpenShift Web Console, in particular, the Web Console on all cloud providers is exactly the same, because that is the Web Console that Red Hat designed, and it's just like in terms of training your developers and kind of making sure that they are fully familiar with what they're doing. If you put that OpenShift on AWS, if you use Rosa, they call it on AWS, Red Hat OpenShift on AWS, or if you're using like the Azure version, it's exactly the same because of the Web Console. So even if the some of the underlying features, for instance, AWS, they've got some of the their great services connected in a way that is more seamless and much easier to kind of integrate into your OpenShift platform. But on the surface, is exactly the same for your developers. From the developer productivity perspective, your developers don't need to be retrained. They don't need to kind of go through another set of kind of skills for that particular cloud platform. Whereas if you're doing VM or some other ways, going from AWS to Azure is not easy. You have to get retrained. Whereas with OpenShift is exactly the same. That's why, for instance, we've got, we are using OpenShift on AWS mainly as our core platform, but we've got other cloud providers as well.
And what about to use these as the cross-cloud solution? If you run applications simultaneously in different clouds, would it be suitable for that?
So Red Hat offers this amazing tool, ACM, advanced cluster management tool, basically. So you can easily see where your application is running, how many clusters, how many, like, the number of resources provided to each one of them. And you can easily shift and, put it on somewhere else and then kind of, move it somewhere else. Like, I don't know if you've seen the demos that Bear Sutter, our friend, basically, he has done. Like, he's done an amazing job showing people how you can actually move your workloads from one cloud to another easily through the dashboard. Again, for very heavy applications and scale, like highly scalable and larger scale application, there needs to be a little bit of more work. It's not just like a drag and drop. But in the majority of cases, through the advanced cluster management, you can actually see what's going on, and you can easily through the dashboard decide where you want to run a particular part of your workload or your microservices. And again, Red Hat is trying really hard to make it easier and easier day by day. As I can see, like, you know, I can see all these conference talks by Red Hat developers, my friends, and I can see that things are getting better and better. You know, Mary and I used to work at IBM as well,
that's right.
so we had some, you know, amazing, you know, experience as developer advocates, you know,
That's right.
across the world. Again, Mary in North America, I had the whole
Yeah.
EMEA region.
Super great. So Red Hat provides us the tools, the management tools for Kubernetes, and Pulsar provides us the very small and efficient performant containers for those applications.
You're a great salesman, Alex. You know, the way you plug that in is amazing.
Thank you,
That's
Mo.
right.
Thank you. Thank you. Dmitry, we have a question on your talk about ARM. Is there a way to be assured that the specific application, what the end user has, would run like firstly run the same way it runs on Intel on ARM, and how do we know that this application would run better on ARM servers? It's probably a bit complicated question.
Yeah, there's a simple answer. You must test it. Like, you run your tests, well, and you select your platform. So you must be sure that your OpenJDK is TCK compliant on that platform, right? Because there's a technology compatibility kit for Java, so you should take a build that passes the testing to be able to run anywhere on that particular platform to run your Java code. Of course, as I mentioned, there are some mistakes that could be made in a program that x86 forgives you. Well, it also happens. You may have external dependencies, because if you start migration, well, it's kind of obvious, but you still have to think about that. Like, you may use Apache Pulsar. You may ask yourself a question. Is there a container, a ready-made container image with Pulsar for ARM ecosystem? Well, actually, there is. It has been released only like last month.
Oh, cool.
That's great.
That's cool.
If it's like production ready, right? But also sometimes it's not the case. Like, you may have a different strategy. We use Kubernetes, and different ISAs can be mixed within a single deployment across clouds, across regions. Because important thing here is that Kubernetes itself works on that architecture. And it allows to run really different machines within same cluster to manage them. Just, you know, that are different. They are different types of nodes, right? And you can specify what pods can exist there or whatever.
Okay, Dmitry. Thank you. We are running a bit out of time. I have a final question. I would like to ask you guys to provide kind of a short answer for this question. Java got its 28th anniversary recently on May 23rd. And my question is, what do you think? What makes Java still popular after 28 years in production, in many organizations, on many developer laptops and desktops? What makes it still alive, vibrant, and so popular?
Well, I guess if you don't mind me starting first,
Would be great.
There are many reasons. I think technology-wise is good, but because myself, I'm a Chicago Java Users Group lead, right? So I tend to kind of think also in terms of the community. I think definitely Java has a very vibrant community, and folks, you know, that are in the community are just so friendly and nice, and then the whole JCP process, all of these things are so good, and actually I have to point out too, because I recently heard, right, some other language groups are having some sort of dispute, right, among themselves, whereas you never hear of it in Java. So I think the fact having a really good community really, really helps, and it's been 28 years too, so it's kind of proven, and also is in a lot of production systems around the world. People may not all be talking about it because it's more of a back end type of thing, but the fact is, it being so robust, I mean, that technology is proved, it speaks for itself too, I think. And then with the strong community ongoing, I think it's really keeping it vibrant, the whole community. So from that perspective, I think it's helping. So
Yeah, this is the great reason. This is the
yeah.
great reason, and I see that there are several generations already within this community. So
Yeah.
they, people, very, 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 very different people, and that it's so exciting. Okay, Mo, go ahead.
Yeah.
I want to say, like, this way, I don't know, Dmitry, sorry if I'm going next. I'm sure you have so many other reasons, but here's my reason. So basically, for those who are listening, I my first experience working for an amazing corporate was working for Sun Microsystems as a developer advocate, open source advocate. We used to be called back then as ambassadors, basically. And again, I worked for Alex. Alex was my boss. And I was only 21 years old back then, which was amazing, just being able to be exposed to that amazing innovation at a big company that was way ahead of its time, all these products, all the open source tools and services for developers. It was just amazing. And again, I started with a very small black box. It was called Sunspots, and I've got right at the back as well, which I basically ended up doing my PhD on that, using Java. But, that ecosystem that Mary just mentioned, that's a very important aspect. All these Java user groups around the globe and all the great conferences. There's still Java One conferences still happens in with different names in different places, obviously, and it doesn't have that much attraction like it had back in 2009, 10 or then. But still, many other conferences are happening around it. Like DevNexus being one of them now has become one of the most popular. We were all at DevNexus in Atlanta, back in April. And I think, the other reason for that from the ecosystem side, beside the ecosystem is, that, runtime environment, the JRE, the fact that it takes care of all the memory management, reallocation, deallocation, all those things that are happening compared to what you used to do with C++, malloc and all the other commands we used to. It's just amazing. You can actually leave it to that, and it will basically take care of everything. And you mentioned garbage collection. That's a very important aspect for many enterprise application of Java that is still today. Java is so relevant in the financial services. If you look at all the core services, there is still Java. You can't really deny that. We've got the largest community of developers, Java developers here at Discover. The same goes for IBM. We had so many developer advocates, so many clients. And it's just because it takes care of things for you. It abstracts all the complexities away from developers. I like to look at it from the technical aspect and the fact that you've got the open source version, OpenJDK, and the enterprise version. It kind of gives you that flexibility. And again, the amazing team at Oracle, they're still adding features to it. They're still evolving the platform. They haven't left it on its own. So there is a company behind it. There is efforts, funding, proper management. So I think for all those reasons, that's why Java is so popular. For me, at least, it's always.
Thank you, Mo. Thank you.
I agree.
Thank you.
Yeah.
Like to be honest, Dmitry showed the chart of the issues fixed, like the implemented features in Java, and there are many companies now contributing to the OpenJDK. That's another reason from my side. Dmitry, would you like something to add?
Yeah, I should agree with all said previously, because Java had great ideas, great concepts, with great implementation being developed rapidly over the time, while keeping the very, very strict backward compatibility. This is something that many other ecosystems, they miss it. So it allowed to build a community which helps to develop the technology and that trusts that technology and has great relationships inside that community, and great ecosystem around that. Because there's one technology that can compete in size, but not in quality. But that's how it goes.
Thank you very much. Thank you very much, Dmitry. Mo, Mary, Dmitry, thank you very much for joining us today. It's really, I'm really grateful to
It's
have
pleasure
you
to see you all
at JRush.
Thank you. Same here.
A pleasure to be here with you.
Thank you. Yeah.
Thank you very much, and have a great day, night, wherever you are.
Yeah.
Thank you. You
Awesome.
too. Cheers.
Thank
Bye-bye.
you, everybody.
Bye-bye.
Take care.
Bye.
Thank you. Bye-bye.